Let's finish the skills that I will be expecting you to know for exam number 1. In addition to being able to iterate over all the elements in a list, as you've seen, there are times when you want to do something for fewer than the full number of elements in the list. In fact, you might find yourself trying to look for a certain value, and once you've found the value in the list, there's no point in continuing the for loop. But the trouble is the for loop will always do something the fixed number of times. So how can you stop the for loop from completing once it's begun? To do this, we need to understand the break statement. And this was one of the self-assessments that I asked you to do to print just the third element in a list. And I encourage you to go look at that on your own. I'm going to show you now an example where the break statement is exactly what you want to do. So I may find myself trying to ask the user for some input. I'll give them 3 chances to enter some value in. And if they don't enter the right value in after 3 tries, then I'm going to say I'm done. But if they enter the right value in the very first time, well, I know I want to stop. So let's talk about that here. How about this? Validate password. So I will say to the following, print, enter password, and I'll make a note to myself, secret password is the number 1, 2, 3, 4. If they enter in that secret password, I want to say something. If they fail to enter it in within, say, 3, maybe 5 tries, then I want to tell them something else. So let's change this and make this work. I want to give them 5 chances to do something. So for I in range of 5. This will iterate up to 5 times. Well, it will actually iterate 5 times unless if I do something about it. And in this situation, I'm going to say, okay, password P is input password. And if they enter in the right password, I want to stop this for loop. If they don't enter in the right password, I want to try again. But I'll only want to do it 5 times. So let me make the following assumption. Let me assume that they don't enter in the right password. So I'm going to say wrong password is equal to true. You've seen different types in the class so far. You've seen integers and floats and strings and lists. Along the way, you've come across true and false. We just covered this when I looked at my conditional expressions. Is 2 less than 10? That's a true statement. So true is a Boolean value. Boolean values can either be true or false. So I'll start here by saying the wrong password is true. If, however, they are able to enter in that magic password 1, 2, 3, 4, then I want to say wrong password is false because they don't have the wrong password. And I want to break. This break statement here will terminate that for loop immediately. When I'm done, I'll just make one final check. If the wrong password was entered in, too bad. So this particular function, it does quite a lot, and this might be one of the more sophisticated functions you've seen in the class so far. So I don't expect you to write this from scratch the first time, but I do expect that you know each of these individual skills, and when I put them all together as I've just done, we have a function that behaves as following. Validate password. Enter password. 456. Nope. Nope. I'm going to do this 5 times. And it says too bad. However, this time, let me enter in the right password after 2 tries. And you see that it stops. It breaks the for loop. And since I actually terminated and my wrong password was set to false, nothing printed here. So the break statement can be very useful. It allows you to stop a definite for loop before it completes, and that gives you some flexibility when dealing with user input. You've seen on each of the lectures different debugging questions that I ask you to solve. These can be very helpful in understanding your own knowledge of the Python language, because you might look at code that runs, but it gives you the wrong value. You don't know why it gives you the wrong value. The only way to figure it out is to understand an arithmetic defect. The ones we've seen so far are what happens when you divide integer division and you end up with a number that's not what you expected. 10 divided by 3 in integer division is in fact 3. But if you wanted it to be 3 1/3, you have to make sure you divide using floating point arithmetic. The other kind of arithmetic defect might be when you divide by 0, something that you should not do, and Python will slap your hand and say there's been a 0 division error and the program terminates immediately. So when you look at code, you should at least be able to understand when a particular mathematical expression is incorrect. As an example, if you wanted to compute the area of a circle, and as you know, the area of a circle is pi times radius squared. And if you had by mistake entered in 3.14159, that's my pi, times my radius, and I meant to say exponent 2, but I just instead said multiply by 2, I get a value, which looks reasonable, but of course it's not the correct value. The correct value should be this. So these are nice ideas as I ask you to solve specific problems. You should be able to look at the code and understand when you've got a defect that's waiting in front of you. Of course, here my defect, of course, is that pi is actually 3.14159. We'll let that go. Syntax defects. This is when you type in code, but it doesn't seem to work, or the compiler, the Python interpreter will complain. The most prominent one that comes up in Python is when you don't use the right number of indented spaces. And for this reason, I'm actually asking you to use Canopy or idle to do your editing, because it will do the indentation for you and you don't have to do it yourself. Here, for example, with that one small change, I now have incorrect indentation. In fact, Canopy is smart enough to point that out for you right here with this little red underbar. When I go to run it, if I try to, it will say, look, unexpected indent, because here this is indentation 1, 2, 3, but this is indentation 1, 2, 3, 4. That's an indentation error that Python has to make sure you keep your indents at the right level. When you indent, you're basically saying all of these statements together are grouped. And in fact, here you've got 3 indentation. One for the, let's start this way, one for the function definition, one for the for loop, one for the if statement inside the for loop, and then one for this wrong password. So indentation identifies bodies of statements, and if you incorrectly indent, that would be a syntax error in Python. Other syntax errors are simple ones like, oh, I put a space in between my less than and my equals, or I didn't do double exponent, I did 3 stars for some reason, and that led to this mistake. Or I meant to do 4,130 times 5, but boy, that doesn't look anything at all like what I was expecting. And this little syntax error here says, yeah, you have to make sure you don't type in commas within your numbers, because it means something totally different in Python. We've covered now the last one I need to cover here is understanding operator precedence and use of parentheses for clarity. So if I really want to do pi times radius squared, then I have to be careful about how I say it. Because watch what happened. I did this in my mistake a little while ago, and that's why I got the wrong answer. Pi, 3.14159, times my radius, let's say 10, squared. This is what I was expecting to get for the area of a circle. But if I had by mistake done this, not by mistake, but you see here, this is the operator precedent. How does it do it? Does it first multiply 3.14159 times 10? Or does it first take 10 and raise it to the second power? Operator precedence is a way that every programming language determines which operators are more important. So you've seen this in regular mathematical expressions on a regular basis. If you say 2 plus 3 times 5 plus 4, well, what is the value? Could it be that you add 2 and 3 to get 5? and then multiply by 5 to get 25, and then add 4 to get 29, it's probably not what I get. What I'm going to get is 21, because 3 times 5, multiplication, is a higher precedent operator than addition. So 3 times 5 is 15, plus 2 and 4 gives you 21. When in doubt, if you don't fully remember the precedence operations for computations, use parentheses for clarification. So if I really wanted 2 plus 3 times 5 plus 4, then I'd better do this. Using parentheses to say first add 2 and 3 to get 5, then add 5 and 4 to get 9. The final last things I need to cover are these string operations. Python has the ability to represent information using integers, floating point numbers, Boolean, and yet all of them in some way can be represented in string form so that the user can understand what you're looking at. When you print something to the screen, for example, print 7, it prints out a string representation of 7. When you print out 7 plus 3, it prints out a string representation of the addition of 7 plus 3. But what if I wanted to print out the number 73? Well, it's actually easy because that is the number 73. But what if I wanted to concatenate together different digits and different strings to come up with interesting phrases? We've seen this before. If I wanted to say, for example, the temperature is 88 degrees. Well, to make this work, you have to concatenate together the parts that are string literals with a number that I might have as a variable, and then the final string here at the end. So let's see how this would look here. Let me come up with a small pretty print. Special print of temp. This special print of temperature will say it is temp degrees outside. As that is stated, this will cause problems. Let's watch. Special print 17. And it's not always easy to know why this happens, but at least Python tries to do a good job telling you where it happened. It says you can't concatenate strings and integers. This makes a little bit of sense. I can concatenate strings, like you see here. I can add together numbers and floats, but when I mix them together, Python gets all confused. So you learn very quickly to use str, which would take some value and convert it to a string. For example, 8 is just the number 8, and I can multiply it, do all kinds of things like that. str of 8 is a string literal representing the letter, or in this case, the number 8. You know it's a string literal because I've got 2 quotes. Once I have string literals, I can concatenate them together. So this will create a single string called it is, a string representation of the temperature, degrees outside. So when I run that now, it's 17 degrees outside. This is actually a well-written function because if I pass in a floating point number, Python is okay with that too. But fine, it's 19.33 degrees outside. So you can convert any number, a float, or an integer into a string using the str operator. The reverse is also possible. If you have a string, like s, and it's equal to 70.3, I can convert that into a float by saying, give me the floating point representation of the string that is given to me. 17.3, you'll see there are no quotes around it. If I try to convert that into an integer, you'll get your hand slapped because it says, look, that's not an integer, that's got a decimal point. And so you have to know in advance what the type is, but that's something that you can easily do in your own programs. So while I can convert strings into integers and floats, I can also convert floats or integers into a string. In these first few lectures, you've also seen a number of other skills that I'm not going to cover on the exam because they are involved in the engineering of software. I've already mentioned that there'll be different modules that you will see in this course, like NumPy or PyLab or math. But on the exam, I'm not going to ask you to use those. So I'm going to safely say that these aren't covered by the exam. And again, for that reason, this ability to import a module is something that you've seen as part of the PyLab demonstration that I did in today's lecture. But you don't need to worry about that for the exam itself.